Next GCSE topic that we'll have a look at today is going to be Pythagoras. Pythagoras was a mathematician who lived over 2,000 years ago. He was a bit crazy, came up with quite a lot of stuff. The main piece of work that we're going to look at is his ideas about right angle triangles. Okay, so two types of Pythagoras questions you mainly see. One where you have to find the longest side, and then one where you have to find one of the shorter sides. We'll take a look at both examples and work from there. Okay, now Pythagoras' theorem, as it's called, was that the longest side, when I square it, should be equal to the two shorter sides squared and added together. Okay, so if we label our triangle, I'll show you now. Okay, 6 and 8, and you'll notice I've put some labels. The longest side, just for as a little side note, the longest side is always going to be the one opposite the right angle. Okay, so I've drawn a little arrow on, and it's actually called the hypotenuse. Okay, so opposite the right angle will always be the longest side. Underneath then, in this box, this was Pythagoras' theorem. Okay, he said that the longest side squared should be equal to the two shorter sides squared and then added together. Some of you may have also seen it as a squared plus b squared equals c squared. It's exactly the same thing, just written a different way round. Okay, so we're going to work through it like that. The first step is to label your triangle. Okay, so we've got C, A and B as our letters. I've labelled them on mine already. The only rule I want you to follow here is C is always going to be the longest side, always the one opposite the right angle. A and B doesn't really matter which way round you do it. So first step then, I write out my formula, C squared equals A squared plus B squared. Now all I'm going to do is I'm going to put the measurements in that I've got and then look to solve from there. Okay, so C I don't know, so I'm going to leave it as C squared. A is 6, so 6 squared, plus B is 8, so 8 squared. Underneath then, C squared equals 36 plus 64. That comes from squaring 6 and squaring 8. If I add 36 and 64 together, I get 100. Okay, so I've tidied it up, and I've got C squared equals 100. Now, to get C on its own, okay, I don't want C squared, I want C on its own. I have to do the opposite of squaring, which is square root. Okay, so C on its own is going to be the square root of 100, and the square root of 100 is going to be 10. Okay, so C in this case is going to be 10 centimeters. Moving on to the second example then, we're going to be looking to find this time one of the shorter sides. So again, I'm going to write some measurements on. You'll notice that the side opposite the right angle, the hypotenuse, the longest one, this time has been given, and one of the shorter sides hasn't been given. So same steps again. First thing, you write out his theorem. Second thing then, you label his triangle. C is always the longest one, no matter if you're given it or if you're not. C is always the longest one. A and B then, as I said, can be either way round. So I've gone on then to substitute in my numbers in place. C squared, well I know C is 15, so 15 squared equals A squared is just going to stay as A squared for the moment because we don't know it, plus B squared is going to be 12 squared. And I'm going to tidy that up. 15 squared gives me 225, 12 squared gives me 144. So I'm left with a new line now underneath. 225 equals A squared plus 144. Now, unlike the other example, where it was a case of add, and then add a square root at the end, this one we're going to do something slightly different. What this means now is some number, when I square it and I add 144 on, I've got to get to 225. Okay, so I need to be thinking now in my head, that when I add 144 to it, I get to 225. You can either think of it just that way and just add on numbers consecutively until you get to 225, or to find the difference, what I need to add on, I can also do a takeaway. Okay, so A squared is going to be equal to 81, and in that little green bubble, that comes from finding the difference between 225 and 144. Now, same thing again. I've got A squared equals 81. To get A on its own, okay, just the letter on its own, I have to add that square root in. So A is going to equal the square root of 81, and if you type that into a calculator or just recognise it, A should be 9 centimetres, okay? So Pythagoras, 2 questions, longer side, shorter side. Same thing to start with, you always write what he said down. Label your triangle, A, B, C. C is always the longer side, A and B, it doesn't matter. 1 is a case of just adding consecutively and then adding the square root at the end. The shorter side example is slightly different. You're going to have to put that step in whereby you take away 2 numbers to find the difference, and then you do your square root. So basically now, anytime that you see a right angle triangle, you should be thinking one of the skills they could possibly be asking you to use is going to be Pythagoras' theorem.